So today we will discuss a new part of motion in straight line. In the previous class, we have discussed about the differentiation and the numericals from differentiation, and we have learned a part of calculus. Differentiation, it is a part of calculus that you will learn in maths more deeper rather than here. Today we'll discuss about the next part of calculus, that is integration, and which is also very much important for us. Talking about integration, you will learn it in class 12 in mathematics, but for physics, mainly for motion in straight line, you have to learn little bit now. Okay. Before starting integration, I'm just telling why we need to learn about integration. See, whenever we have learned differentiation, I have shown you the physical signification of differentiation is to find the slope of a curve. Okay, so our target is to find the slope. Then you might be asking, sir, what is the utilization of this slope? We know that the slope of displacement time graph is velocity, and slope of velocity time graph is acceleration. That means if displacement is given to us, I can able to find velocity by differentiating it with respect to time, and by differentiating velocity with respect to time, I can able to find acceleration. But apart from this also, by the help of graph, we can able to calculate many more another thing also. I'm just giving you a hint. Remember, whenever we have learned velocity time graph, okay, so at the time we have learned about the velocity time graph, remember, along x-axis we have taken time, along y-axis we have taken velocity, and if a body moves with a constant acceleration, then the graph seems to be like this, and this distance is known as initial velocity, and here this height it is taken as final velocity v. If I want to find the distance covered by the body, what we have done, we have to draw a straight line from here. Assume this point is A, this is B, this is C, and this is D. If anyone asks you how you can able to find the distance from a velocity time graph, so you can say, sir, whenever we will find the area of the graph with x-axis, by that way we can able to find the total distance. So the area of the graph with x-axis will give us the distance from velocity time graph. Now it is asked how you can able to find the area. There are two ways to find the area. First one, it is a trapezium. We know the equation of area of trapezium, that is half of sum of parallel lines into height. Or you might draw a straight line here, and it is a triangle and it is a rectangle. So find the area of the triangle, find the area of the rectangle, and add these two. It is very easier for us to find the distance from velocity time graph if the graph shown is like this. But assume if the graph is given to you like this, the velocity time graph, if it shows like this, you have to find the distance. Now it is clear that to find the distance, we have to find the area of this portion. But there is a problem. It is not a regular shape. It doesn't have any equation to find the area of this kind of shape. Then how we can able to find distance from velocity time graph? So for that reason, we need to find one important part of calculus, that is integration. So that with the help of integration, I can able to find the area of this irregular shape also. So I think by this idea I can help you to know what is the need of integration to find what is the need of integration in motion in straight line. So by integration, see, integration means we want to integrate something, we want to add something, we want to find the whole thing, whole aspect, that is the whole area. If it is a regular shape, we can easily find out, but if it is irregular shape, then it is difficult for us. Okay, so let's see how we can able to find the area with the help of integration. Assume two quantities are given to us. So we have placed it like this, along y-axis and along x-axis. So along y-axis, what quantity we have taken, that is y, we have told it is a function of x. That means by changing the value in x, right, the y is changed. Okay, now see what type of graph it will show. So let's see an arbitrary graph. Just assume the graph seems to be looking like this. So it is the graph that shows the relation between y and x. Okay, assume this point is a, this point is b. Follow the steps what I have done. See, this derivation will never come in exam, but if you understand once, it will helpful for you for your next classes also, because this thing you will learn in maths also. So if you learn it properly, then it will help you. So if I have drawn a perpendicular here, so assume the distance along x-axis, it is a. Okay, and here if I have drawn along y, this is y1, right? So this is y1 and that distance along x-axis, it is a. So can I write, as y is a function of x, so we can write y1 is equals to function of a, because here the value of x is a. So y1 is it is a function of a. Now from the point B, I have drawn a perpendicular here. Assume this distance, it is b, and the height, it is given here. Assume it is y2. So we can write here that y2 is equals to function of b. Now what is told to us? Assume we have given the name. Assume it is c, it is d. So we have to find the area of A, B, C, D. We want to find the area, this A, B, C, D. How we have to find it? So to find the area, we have to play a trick. What tricks we have to play? Now, this whole area, we have to divide some stripes. Okay, we have to divide the whole area by some stripes. So if I find the area of the stripes, then we have to add the area of the stripes and we will get the total area. I am not giving anything here. Just assume I have given a demo here. What we just want to do, this is the graph, this area we want to find out. So I am just giving some stripes like this. I'm just dividing the whole portion into some stripes of same width. Same width. Assume the width is delta x. Now separately I have to find the width of each stripe and then add it. Okay, and then I can able to find the area. So what we have to write here? Let n number of stripes of width delta x is taken through the whole area. Okay, by adding the area of each stripe, we can get the whole area. Okay, so we have divided into stripe, and by finding the area of each stripe and then adding it, I can able to get the whole area. But here we have seen some problems. What is it? If I'm talking about the stripe, if I've drawn a straight line, okay, I can able to find out the area of this stripe because the height is known. This height is also same, so it is a rectangle. I can able to find this area. I can able to find this area also. It is very easy. I can able to find this area also. Okay, but you see, if I have done this, there are some areas are left. This one, this one, this one, this one. These are the left areas. So now if you see that if we find the area of the stripe and we will make the calculation, then we will not get the exact area because some of the areas are left. Okay, if we are using it by the help of the stripes. Now what we think, now if I just decrease the width of the stripe, the tail x, if I decrease it, then the left areas maybe it can be abolished. Now you might be thinking, what's that is telling? So let's see. Previously, what width we have given, now what we are doing, the width of the stripes we have decreased. Okay, so if we decrease the width like this way, now you see the lost area, it is very less. See, it has come like this. Very less area it has come. Initially, how much area we have seen, but if I decrease the width of the stripes, then the left areas or lost areas, these things are going out. So what thing we have to assume here? Now what stripes we have taken, the width of the stripe del x should be very less. How much? So let's write it. So it is assumed that the width of each stripe should be very small. That is, del x will be small. How much small? We are assuming that del x should be tends to 0. Means the width should be so close. Okay, so if del x tends to 0, that can be represented by dx. If del x is so small, so it can be taken as dx. So in the first graph, we have to assume that stripe. Okay, so here I am taking little long, thicker stripe because to take very thin, so it is difficult for us to draw. Okay, but we have already assumed the thickness, this thickness, it is dx, and which is very small. So by dx only, dx means the small width or the small length we are assuming. And how many stripes we have assumed? we have already assumed there should be n number of stripes. Okay, n number of stripes. Okay, so if there are n number of stripes, so we can write that n equals to b. So b is this value from 0 to here, the point C, minus a, okay, by dx. So that will give us the value n, b minus a by dx, because dx is the separation or the width of each stripe, and there are n number of stripes we have assumed. So what we have to do? We have to find the area of each stripe. So if I write area of stripe, so area of stripes means first area will be how much? So you see it's a rectangle. Okay, it is almost a rectangle. So if it is a rectangle, so first one is A, right? So at a distance of A, this much length is y1, and y1 is known as FA. Okay, and the width is delta x. So first area will be f of A into dx, f of A into dx, next area plus. So when we'll come to the next line, so then you see the function, it is changed. Why it is written a? Because the value of x is a here. That's why it is function of a. Try to understand. The value of x is a here. That's why y1 is function of a. But when we shift it to the next, now this is increased by dx because it is a plus dx, this. Okay, so it should be function of a plus dx into dx because the width is same, dx, plus f of a plus 2dx because dx, 2dx, 3dx, 4dx into dx. Just follow how I can able to give the areas, and by that when we have to go at the end, when we'll come to this line, this is the line before the end line. So if I am talking about the stripes, the last one is n number of stripe, and before it will be n minus 1. So we can write it f of a plus n minus 1 into dx. Now you might be asking why I have written n minus 1 into dx. Because the total stripes are n. If I want to find the previous line here, okay, this into this portion. Okay, so this length, it will be f of a plus n minus 1 dx. So dx. Last one is n dx. But before it, n minus 1 dx into dx. So you'll get this area. And here also you have to see in some places are vacant. But if these two lines are too close, so these places will not vacant. And we have already taken that del x tends to 0. And that's why it should be taken as dx. I know that concept is not very easy what I have told directly. So feel it. I'm telling you, you feel it. First stripe, okay, and then dx. This one is f of a and this is dx. First area is over because it is at a distance of a. But next one, assume this is the next stripe. So now this length, it is changes to f of a plus dx or del x, whatever you can take it, because it is a and here it is coming delta x after, and then into delta x, this area. So like this it will propagate. That is the way we have taken and finding out the whole area. Okay, if I want to write it in a form of summation, because if it is coming continuously we can write it in a form of summation. So it is denoted by I dash summation I equals to 1 to n, okay, f of xi into dx. So you see the value of I is changed. When its value is a, so it is a. When its value is changed a plus del x, so it is changing to a plus del x. Okay. So I think the derivation, it is clear to you. But there is a problem. What is the problem here? Problem is, whenever we are taking summation, the summation will have certain rules. What are the rules? Now we can use summation if the function is discontinuous. Meaning, what is the meaning of discontinuous and continuous function? I'll help you. Assume it is given, it is y equals to 1 square plus 2 square plus 3 square plus dot 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 plus n square. You have to find the sum of this. So it can be written as y equals to summation of I equals to 1 to n xi square. Okay, so first the value of I or x, it is 1, so it is 1 square, plus then it is 2 square, then it is 3 square. Now you see, when we are talking about 1 square, 2 square, 3 square, dot dot dot, whatever it may be, these things are totally separate with each other. 1 square means 1, 2 square means 4, 3 square means 9, 4 square means 16. All the numbers are separate. Okay, but whenever we have to see the shape, here we have to use summation, but you see, one by one, these are very much continuous. They are not separate, they are not distinct, just like we have seen in this function. Okay, so for that reason we cannot able to use integration here. So as f of x is a continuous function, so here summation is not used. So we cannot able to write the things like this way. Rather, what we can do, so for that reason we have introduced one another thing that is known as integration. Instead of summation, we have introduced integration. So integration I equals to function of x dx. Okay, now this sign, you see, this sign seems to be S. You see, it's just looking like S na? S means what? S means summation. Summation of continuous function. And whenever we have to use this one, it signifies that it is the summation of not a continuous function, it is discontinuous function or integrated functions. Okay, I'm sorry, disintegrated function. And whenever we have to use this sign, it represent integrated function. Okay, that is continuous function. And this is used to find the area of the whole shape. Okay, whose equation is not known by us. Clear? So that is integration. By differentiation we are finding out the slope, and by integration we just want to find out the area of the curve with x-axis. Clear? So at the end, by this diagram, what we can conclude from here, that the total area I, where the smaller stripe delta x, which is tends to 0, that should be represented by summation over I equals to 1 to n f of x I into delta x, which can be represented by integration of f of x dx. Okay, and here one thing we have to keep, see, it is starting from the value of x a and it is going up to the value of x b. Okay, so starting from this point to this point, so we have to provide a limit. It is called a limit. So from a to b f of x dx, that will give the area of the shape A, B, C, D. Okay, this will represent the area of the shape. Okay, now if we go more detail in integration, so when we integrate something like f of x dx, we will get another function f of x, okay, which is completely different. Just like here we have find I, which is the total area, the integrated portion of the whole stripes. So integration of f of x dx, that is the integration of smaller tribes, give us the total area, that is f of x, capital F of x. So that is another function of x. From here, we can say that there are two types of integrations are there. One is known as definite integral and another one is known as indefinite integral. So what is definite integral? Now in an integration, if we have certain limit, just like a to b we have given here. Limit means we have given the boundary of the area, that you have to start from A and you have to end at B. Okay, and that integration of A to B f of x dx, so that case what function we will get f of x, that will also have a limit A to B, and that can be represented by, this is the upper limit and this is the lower limit. This is the upper limit, the highest limit, and it is the lowest limit. So here instead of x we have to write f of b minus f of a. Always you have to remember that upper limit minus lower limit. So you might be thinking, what is it, from where it has come? Whenever we have to do the numericals, then this idea, it will be clear to you. So first one is definite integral. Though first is indefinite, but here for physics we have to learn definite integral first. And next number two is indefinite integral. In indefinite integral, the rules are same, just like the definite integral, but there is no limit. Assume if the limits are not given to you, that is integration of f of x dx, no limit is given. So in that case, it can be represented by a function f of x plus c. What is c here? C is known as integral constant. Okay, and here no upper limit minus lower limit should be done, because here no limit is given. Only we have seen that for the case of definite integral, after integration we have to put the value of the limits, and for indefinite integral, as there is no limits, so we have to write the function after integration, plus we have to add an integral constant. Why? The reason we have to learn later. The reason You will get it later. Why this c has come. Okay, so this is the theory of integration. Now we have to see some common function and their integrated function. Okay, let's see. So integrated value of some common function are written here. Okay, just like in case of differentiation how we have done, same thing we have done for the case of integration also. So if you take x to the power n as a function, then its integration will be x to the power n plus 1 by n plus 1. Same thing, I have shown you some example. If it is x to the power 4 dx, assume, so it should be, so here the value of n is 4, so it is x to the power 4 plus 1 by 4 plus 1. Okay, and here as you see no limit is given, I have to write one c here, that is as integral constant. I have told it is indefinite integral, so it will come x to the power 5 by 5 plus c. But assume if it is a definite integral, just like same function x to the power 4 dx, assume it is varied for 1 to 2. The limit, it start from 1 and it will end it at 2. Then what will be its integration? It will be same, that is x to the power 4 plus 1 by 4 plus 1. But here we have to not write c. C, it is only when no limit is given. If the limits are given to you, you have to know, you shouldn't write any c there. So it is x to the power 5 by 5. Now you have to draw, you have to write here the limits 1 to 2. Now what you know, it is upper limit minus lower limit. Upper limit means in the place of x you have to write 2, that is the use of upper limit. So 2 to the power 5 by 5 minus, then lower limit, upper limit minus lower limit, so 1 to the power 5 by 5. So in place of x you have to write the value of the limit. So here 2 to the power 5 means 2 to the power 3 is 8, 8 to the 16 and 16 to the 32. 32 by 5 minus 1 by 5. So it is 31 by 5. That is the answer. So like this way we have done integration. If we have seen a function of x to the power 4 dx. Okay. If it is x to the power 3 dx, so it is very easy. X to the power 3 plus 1 by 3 plus 1, because n plus 1 by n plus 1. But as there is no limit, you have to take a constant. So x to the power 4 by 4 plus c. Our integration is completed. Right? From here, I just want to show one interesting thing. So the first part it has done. But in the first part, one thing is left. What is it? Assume instead of any function, we have not given anything. Just like integration of dx. Then what should we do? If it is an integration of x to the power 3, x to the power 4 or something like that, we can able to do. But if it is only integration of dx, no function is given. So what can I do here? So integration of dx means we have to understand that it is 1 into dx, right? 1 means this 1 can be written as x to the power 0 dx. So something to the power 0, it should be 1. So you might be asking, so why it is x to the power 0, why it is not any another number? Because as it is a function of x, it is dx, so we have to take it is x to the power 0. So as we have got power once, then here the value of n is 0. So then 0 plus 1 by 0 plus 1 plus c. 0 plus 1 means x, 0 plus 1 means 1. So x plus c. So we have to remember integration of dx means x plus c. integration of dx equals to x plus c. Okay, I think it is proved. Now coming to the another function, integration of sine x, it will be minus cos x. Why? That derivation is given in your math book. If you want, I can do, but unnecessary the video will be long. I don't want to make it large. Okay, so make smaller the things you have to remember. Integration of cos x equals to sin x. Integration of sec square x equals to tan x. Integration of cosec square x equal to minus of cot x. Integration of sec x tan x equals to sec x. Integration of cosec x cot x equals to minus cosec x. For now, this class you have to remember this thing, nothing else. Integration of 1 by x equals to ln x. Integration of 1 by x square plus a square equals to 1 by a tan inverse x by a. That derivation also you have to learn in class 12. Okay. Integration of 1 by root over of a square plus a square, it is sine inverse x by a. So this inverse function you have to learn in class 12. For now, this class you have to remember, and for especially if I am talking about class 11, you have to remember only these three. Rest of the thing it will never come in exam, and sometimes this one. Okay, rest of the things it will not come in exam. But whenever we have seen the function, you see one thing, it might be comes to our mind, that in differentiation what we have done, we have seen the things are opposite in case of integration. See, in previous function we have seen the differentiation of ln x 1 by x, and here we have seen integration of 1 by x equals to ln x. Previously, differentiation of sine x equals to cos x, and integration of cos x equals to sine x. Previously, differentiation of cos x equals to minus sine x, and now integration of sine x equals to minus cos x. So differentiation and integration, is it exactly opposite to each other? Yes, and that explanation will give, but you have to prepare with that. That's why whenever I have written the function, I have just make that thing into your mind, that integration, the functions we have seen, it is exactly opposite what we have done in differentiation. Okay, elaborate explanation I'll do. Now you see, when we are talking about the rules, so here you have to just remember two rules. One, if any constant and any function with integration is given, the constant will come outside, just like the differentiation. Just like if it is given integration of 5x dx. Okay, so integration of 5x dx means the 5 will come outside, x dx. So x dx means here the power of x is 1. So it is x to the power 1 plus 1 by 1 plus 1 plus c, as there is no limit. So if there is limit, then upper limit minus lower limit. So it is 5x square by 2 plus c. Just like when a constant is given, the constant will come outside. And if two functions are given to you, either in a form of addition or in a form of subtraction, what we have to do? Now we have to treat it separately. Okay, just like assume a function is given to you like this. Where we should erase? I should erase this thing. I think you have remembered this one. Assume two function is given, just like 5x square plus 2x integration of dx. Okay, so we have to separate it, just like integration of 5x square dx plus integration of 2x dx. Okay, so the constant will come outside, so 5 when it will come, so x square means x to the power 2 plus 1 by 2 plus 1 plus 2 into x to the power 1 plus 1 by 1 plus 1 plus c. Now you might be asking, sir, Previously we have done one integration and that's why one constant we have taken. So here we have done two integration. There also one constant. Yes. So constant we have to take one. Okay. So for different integration we will not increase the number of constant. So constant should be one. Clear? So it is 5x cubed by 3 plus 2x squared by 2 plus c. So 2 will be cancelled out. 5x cubed by 3 plus x squared plus c. Okay. So these are the rules of integration. These are the rules of integration. Now we'll see some example what we have just do in the exam. So what type of questions may come from integration? Assume it is told to you that the velocity v of a body, it is 16 t cube plus, make it 15 t cube plus 8 t square minus 3. Okay, so the velocity of a body, we know that velocity is definitely, it's a function of t. So the equation we have written, so there the t functions are given. So v is 15 t cube plus 8 t square minus 3. If from here it is told to us that we have to find the distance, that find distance from 2 second to 5 second. Find distance from 2 second to 5 second. So as the velocity is given, so we know the integration of this velocity, that will give us the total distance, because velocity time graph it is given to us. If I find the area, then we can able to find the distance. And how we can able to find the area? By finding integration. Okay, so distance is equals to integration of v dt. Now you might be asking, so just now we have done dx, why dt has come? Because along x-axis here we have taken t, and along y-axis we have taken v. So that's why it is dt. So v into dt means it is a function of t into dt. So what is the function of t here? Integration of 15 t cube plus 8 t square minus 3 and whole into dt. And there is a limit given to you. The limit of time, it is from 2 to 5. So definitely it is a definite integral. Okay, limit is given to you. So first we have to do the integration, then we will go for limit. So 2 to 5, 15 t cube into dt plus 2 to 5, 8 t square into dt minus integration of 3 into dt 2 to 5. Okay, step by step come here. Okay, so it is initially I think I have written right, otherwise there will be problem in calculation. So make it 16 t cube. Okay, 16. Okay. So first 16 will come outside, integration of t cube dt. So I am just missing a step and directly written t to the power 3 plus 1 by 3 plus 1, and its limit should be 2 to 5. You have to mention the limit like this way, plus 8, it will come outside, t to the power 3 by 3. Okay, better here also we have to take 9. Okay, then the calculation will be easier, it will be cancelled out. So take it 9. Okay, and minus, and here also limit you have to mention 2 to 5 and 3 dt. So integration of dt means t, integration of dx is x, so integration of dt is t. So 3t limit 2 to 5. Okay, now let's calculate it together. So 16 t to the power 4 by 4, so 4 4s are 16 plus 9 t cube by 3, so 3 3s are cancelled out, so it is 3 t cube minus 3t and whole into the limit it is given 2 to 5, because we have not used the limit. Now we have to do upper limit minus lower limit. So upper limit means we have to put the upper value. So in the first part it is t to the power 4, so it should be 5 to the power 4 plus 3 into 5 to the power 3 minus 3 into 5. Okay, so that is the first part, that is the upper limit minus lower limit. Lower limit means 2 to the power 4 plus 3 into 2 to the power cube minus 3 into 2. Okay, so this is known as upper limit minus lower limit. Upper limit means in the place of t I have to write 5, and lower limit means we have to write 2. So 5 to the power 4, 25, 5s are 125, 125, 5s are 625. Okay, so 625 and it is 5 cube means 25, 5s are 125, 125 into 3, so 3 5s are 15, 3 2s are 6, 1 7 and 3 minus 15. Okay, so this is the upper limit portion minus lower limit. 2 to the power 4 means 16 plus 3 into 2 cube means 24 minus 3 to the 6. Okay, and now write the value. If we add it, minus it first, so it will come directly 60, 360, 360 plus 625 minus 10 plus 24. So let's do it first. 5 8 9, okay, minus 34, so it is 1 5, okay, 951. Okay, so this much if the velocity it is given in bracket meter per second, so the distance it will cover 951 meter. Okay, so this is the way the numericals may come in the exam. Okay, now we will do much numerical, but not in today's video. In today's video we'll discuss one more interesting thing, whether the differentiation is opposite to the integration. Let's see. Sorry students, there is a problem with the board, so that's why we have to write it in a paper, the last part of this video. So please see it, and if any doubt I'll clear it. So the last part we're going to discuss here, that we just know integration, and now we have to learn what is the difference between integration and differentiation, the two part of calculus. So if we see the differentiation is the opposite of integration. So just now whenever I have discussed about that chart, and where I have shown the functions and the integrated functions also, there I have already told that integration of 1 by x will get ln x, and the differentiation of ln x, that will give us 1 by x. So by the example only you have seen that differentiation is the opposite to integration, but how they are different with each other, let's discuss about that. If I have written differentiation and here it is integration, what is the difference? So when we have differentiate anything, there we just find the gradient of a function. So this gradient term is little new to you. Gradient means by change of one quantity, how the another quantity changes. Example, if I've written y is a function of x, so if I change x, how does the y change? And that's why we written the change y dash equals to dy by dx. Means by the small change of x, that is dx, how much y is changed. That is differentiation. And by that we have find the gradient of a function. And it can be written as f dash x also. Okay, what is y dash? That can be written as f dash x also. So f dash x is basically dy by dx. And in a graph we have seen we can able to find slope of a graph. So by the help of differentiation we can able to find the slope of a graph. Okay, to tell the truth, if I have told that this is a graph, assume it is y and assume it is x, so we have just find out by just small change of x, assume if there is a small change in dx, how much y is changed, that is dy. And by taking the ratio dy by dx, we are finding the slope. Okay, by changing the x, how much y is changed. That is all about our differentiation. Means we just find the smallest part of a graph. Rather, whenever we have come to learn about integration, that by integration we find the area of a graph along x-axis. So by integration we are finding the total area. Means we just want to integrate the whole thing. If it is y, if it is x, I just want to find the whole thing. Okay, that means in differentiation we just find the smallest stripe. And here what we have done just now, we have done it that we are finding the stripes, and by adding all the stripes we will get the total area. How? If I'm talking here that if y equals to function of x and its differentiation gives us f dash x, we have seen here, and here the integration I will give integration of f of x dx. Now by seeing this idea, you might be thinking that these two things may be different, but I'll make it clear how they are equal. Okay, let's see. Here I have told that y dash is equals to dy by dx. And what is y dash? Y dash is also a function of x, but the function is different, that is f dash. But if I want to find dy, so dy equals to f dash x dx, right? So here if I find to y, so dy is the smallest portion, and y means we have to find the total y, so we have to integrate f dash x dx. So by this thing, what I just want to say, that by differentiation what the things will get, will return it when we integrate it. I'm doing it again, that y is function of x. If I differentiate, that is dy by dx, it will give another function, that is f dash x. Okay, sometime we have to return it by f, capital F of x. Okay, or f dash x is the general thing we have used. And now if I want to find y again, f dash x dx. So y equals to integration of f dash x dx. Then I again get this y, and that is f of x. Let's see an example. Then your idea will be clear. Let y is equals to x cube plus 4x square minus 5x plus 6. This is a function. Assume by this we have represent one function. Here it is clear y is a function of x. Now if we want to differentiate it, dy by dx. So x cube means it will come 3x square. 4x square means it will 4 into 2x minus 5 plus 0. Okay, I am not breaking this portion, I am just skipping one step and I have written directly. So it is 3x square plus 8x minus 5, and that is your dy by dx. And from here if you want to find dy, so dy equals to 3x square plus 8x minus 5 into dx. And now here if you want to find y, what I have just told you, have to integrate it. So this function you can tell it is f dash x. Initial function you have to tell it is f of x. Okay, so it is f dash x dx means 3x square plus 8x minus 5 dx whole integration. So if you integrate it, integration of 3x square dx plus integration of 8x dx minus 5 dx. Now you see here I have not given any limit. So what type of integration it is? It is an indefinite integral. Okay, as there is no limit, so let's do it. 3x square, so 3 into x to the power n plus 1 by n plus 1 means x to the power 3 by 3 plus 8 x to the power 2 by 2, 1 plus 1 by 1 plus 1 minus 5x as usual. Okay, and here as it is indefinite integral I have to add one c. Now you will understand why we add c here. 3 will cancel out, 2 4, so it is x cube plus 4x square minus 5x plus c. Now the question has come. So whenever we have to see the previous function y, there is a constant 6, but here we don't get 6, instead of it we'll get c. For that reason only we are using that c, that is integral constant, because when we differentiate one constant we'll get 0, but by integrating we get that type of function which should have x, but we don't get the constant. You see, the constant 6 we don't get. So we don't know whenever a function is given whether it is ended at here or there is much constants are given. So as we don't know, arbitrarily we have taken a constant. Okay, now you might be asking, sir, can I able to find the c will be 6? If the values are given here of x, then you can able to find, otherwise you will not get what constant is given or constants are given. Here maybe 6 plus 3 plus 5 minus 2, it may be more, but we don't know what constants we can get or we can return. That's why for indefinite integral we have given directly the c, and you see rest of the functions are same exactly what we have done or what it is given earlier. So that's why we can say the differentiation is exactly opposite to the integration. Okay, so from here what conclusion we can make? So let's see the conclusion portion. Okay, so last one, conclusion. So the conclusion portion is very interesting. Number one conclusion from calculus means both differentiation and integration. We know that differentiation of displacement, because as we are talking about motion in straight line, so we will deal with these quantities. So differentiation of displacement gives us velocity, or rather you can say differentiation of displacement with respect to time gives us velocity. Okay, so we can write it, if y is a function of t where y is displacement, then our velocity v equals to dy by dt, that is f dash t. That is our velocity. Okay, in another one too, that is differentiation of velocity with respect to time gives us acceleration. That means if velocity it is another function of time, then we can say that acceleration it is dv by dt, and it can be written as g dash t. Okay, so g dash is the another function. Okay, another way we can write it is a special thing, that double differentiation of displacement with respect to time gives us acceleration. How? If the displacement y equals to function of t, so v equals to dy by dt, just now we have done, that is f dash t, and dv by dt, that will gives us a, and dv by dt means it is d2y by dt2, that is the double differentiation, and that will give us acceleration, or it can be written as f double dash t. Okay, so that we have learned from differentiation. But when we have learned integration, integration is exactly opposite to the differentiation, so we can conclude from here, that is number 3, that is integration of velocity gives us displacement. How? Because we know that v equals to dy by dt, and dy equals to v dt, and y equals to integration of v dt, and integration of v dt gives us the displacement. And in another way, integration of acceleration gives us velocity. Okay, just reverse thing, acceleration equals to dv by dt, and here dv equals to a into dt, and v equals to integration of a dt. Okay, so very common thing, if it is displacement, differentiate it, you will get velocity, differentiate it, you will get acceleration, and in reverse way, integrate it, you will get velocity, and then again integrate it, you will get displacement. So these are needed to understand what we have to do with the help of this differentiation and integration. Okay, so let's see only one example. I'm not giving much, I'll just give only one example, and for by that we'll just end it and go by a new thing. Okay, so assume it is given, let acceleration a is given to you 3t square plus 2t plus 2. It is the acceleration it is given to you. Okay, and it is asked you find velocity and displacement in time 1 second to 2 second. Okay, here I have given limit. Previously I have not given limit. So if no limit is given, then extra c will come to justify the constant in a function, because differentiation of this constant will be 0. So by integrating, the constant may come. That's why the integration, the constant I have taken. Now a, it is equals to 3t square plus 2t plus 2. A means dv by dt, that is equals to 3t square plus 2t plus 2. Okay, and here v equals to integration of 3t square plus 2t plus 2 time 1 to 2 second. Okay, now integrate it into dt, and here 3t square integration 1 to 2 dt plus integration of 2t dt plus integration of 2 dt, 1 to 2, 1 to 2. So 3t square means 3t cube by 3 limit 1 to 2 plus 2t square by 2 1 to 2 plus 2 into t 1 to 2. The reasons I have already explained just now in board. Now 3 will be cancelled out, 2 will be cancelled out. So upper limit minus lower limit. So in first case, upper limit is how much? 2 cube. Okay, lower limit is how much? You can directly do it here, 1 cube. Its part is over, plus 2 square minus 1 square and plus 2 into 2 minus 1, because here is only t, that's why 2 minus 1. Now put the value, it is 8 minus 1, that is 7, plus 4 minus 1 3, and 2 minus 1 1, so plus 2. So 12 meter per second. If the acceleration given in SI, it is meter per second square, so velocity will come in 12 meter per second. Now if it is told us to find the displacement, okay, so to find the displacement we will just find the differentiation again, so the integration again. Why? Because here the v has come integration of 3t square plus 2t plus 2 into dt, and here it is an indefinite integral. Okay, here it should be an indefinite integral. So if I do this indefinite integral, what it will come? I am writing directly. Okay, so it is 3t cube by 3 plus 2t square by 2 plus 2 into t plus c, because here we will not use any limit. Okay, so 3 will be cancelled out, 2 will be cancelled out. So v equals to t cube plus t square plus 2t plus c. Now c is integral constant. Now you might be asking, sir, why we are not using any limit here? So here we are not using any sort of limit because we just want to find the function, not the value. Here you see the value has come, but here we want the function, what function of time that velocity is. And now velocity equals to what? ds by dt, that is equals to t cube plus t square plus 2t plus c. And now here find s. So s equals to t cube plus t square plus 2t plus c dt integration. So if you do it here, t cube means its integration will be t to the power 4 plus 4 t square means t to the power 3 plus by 3 plus 2t square by 2 plus c into dt. So it is c into t plus, as it is another integration, we have to use another constant c dash. So c dash here it is integral constant. And if you want to give the limit, then no need to add this c dash. If you not want to give, then c dash. And if you give the limit here, then do upper limit minus lower limit. So here no need to give. So c 1 to 2 s 1 to 2, if you find, so it will be t to the power 4 by 4 1 to 2 plus t to the power 3 by 3 1 to 2 plus 2t square by 2 1 to 2 plus c t 1 to 2. But here c dash is not needed as you have given the limit. Okay, now you might be asking, sir, what is the value of c here? We don't know, as it is a constant we have taken and we don't know the value of the c, so let it be just like c. So t to the power 4 by 4. Okay, so 2 to the power 4 by 4 upper limit minus 1 to the power 4 by 4 lower limit plus 2 cube by 3 minus 1 cube by 3 plus 2 will be cancelled out, 2 to the power 2 square minus 1 square plus c into 2 minus 1. Clear? 2 to the power 4 by 4 means it is 16 by 4. So it is 4 minus 1 by 4. 8 by 3 minus 1 by 3. And my plus 4 minus 1 plus c. So 16, so 15 by 4. 7 by 3 plus 3 plus c. Okay, so if you write it together you can do it. Okay, so 15 by 4 into 7 by 3, so better you have to calculate it here from 9 3 3s are 9 and 9 minus 7 2, so 15 by 4 minus 2 by 3. Okay, and here plus c. And now you calculate 15 by 4, so LCM will be 12, 4 3s are 45 and 3 4s are 8, so 45 minus 8, it should be 37, so 37 by 12 plus c. This much of meter if the unit is in SI. Okay, so these are the calculation we can do in integration. So we will practice much numerical on that. So from today it is over.